Let's look at the process of differentiation. But first, let's look at the concept of derivatives. Assume that we have a function y, and this y is a function of x. So x is the independent variable, and y is the dependent variable, dependent on x. Now let's assume I increase the value of x by a very small amount, delta x. What effect would it have on value of y? The new value of y is given by the following function. So when x undergoes a change in its value by delta x, y would undergo a certain amount of change in its value as well. Let's denote it by delta y, defined by the value of y evaluated at x plus delta x minus the value of y evaluated at x. Now let's calculate the following ratio, delta y over delta x. Now from these definitions, delta y over delta x is quite simply yx plus delta x minus yx over delta x. Let's see what happens if you let delta x to go to 0, if you take the limit of delta x approaching 0. At a first glance, you would guess that this ratio, delta y over delta x, would tend to go to give you the following ratio, which is indeterminate. Since when this delta x goes to 0, yx minus yx is 0, delta x goes to 0, and that will give you the denominator 0. But in general, this ratio approaches a limit as delta x tends to 0. And that limit is usually written as dy dx, what we call the derivative of y with respect to x. And so we have the following definition for derivative dy dx. It is quite simply the limit for this ratio delta y over delta x as delta x tends to 0. The process of finding this limit is called differentiation. This is a fundamental definition of derivatives. And finding derivatives from this fundamental definition, it's called differentiation from first principles. To understand this technique, let's look at a few examples. Example 1. Let's assume y has a following simple dependence on x. To find the derivative dy dx, of course we need to calculate the limit of the ratio delta y delta x as delta x tends to 0. So delta y equals the value of y computed at x plus delta x minus the value of y computed at x. Y computed at x plus delta x for this function is quite simply x plus delta x squared, and yx is just x squared. X plus delta x squared is quite simply x squared plus 2x delta x plus delta x squared. And from that we subtract x squared. So x squared minus x squared, that's 0, and you are left with this balance. Note that this entire thing is delta y. So delta y over delta x is quite simply 2x plus delta x. Now let's see what happens to this ratio as we take delta x and let it to go to 0. The answer is 2x, and that is the derivative from the definition. So dy dx for this function is quite simply 2x. Let's look at another example. Y equals cosine of x. let's determine the following ratio, delta y over delta x first. Delta y equals y evaluated at x plus delta x minus y evaluated at x. So that means for this function, it is cosine x plus delta x minus cosine of x over delta x. Note that this term here can be expanded using trigonometry identity. It is quite simply cosine of x cosine of delta x minus sine of x sine of delta x. Subtract cosine of x, that is this function right there, over delta x. Next, let's evaluate this ratio as delta x tends to 0. When that happens, let's look at this term. When delta x tends to 0, cosine 0 is approximately 1, whereas sine delta x will tend to delta x itself, because sine of theta will approach theta when theta goes to 0. That's the limit. So this ratio under this limit will simply become cosine x minus sine x delta x minus cosine x. This cosine x is that term right there, over delta x. So cosine x minus cosine x, that's 0, and this delta x will cancel that delta x to give you minus sine x. So this is indeed the derivative of y with respect to x for this function. Third example, what if y equals to 3x plus 2? So here, y evaluated at x plus delta x is quite simply 1 over 3x plus delta x plus 2, whereas delta y is quite simply the difference between y evaluated at x plus delta x and yx itself. So this is quite simply 1 over 3x plus delta x plus 2 minus 1 over 3x plus 2. So delta y will become 3x plus 2 minus 3x plus delta x plus 2. So we are making the denominator equal, and the denominator is quite simply 3x plus 2 times 3x plus delta x plus 2. You see that this 3x will cancel that 3x, this 2 will cancel that 2, and the numerator is left with only minus 3 delta x. So this delta y will simply become minus 3 delta x over 3x plus 2 times 3x plus delta x plus 2. That means this ratio delta y over delta x is minus 3 over 3x plus 2, 3x plus delta x plus 2. Now, in order to calculate the desired derivative, we need to calculate the following limit of that ratio, namely the limit when delta x tends to 0. Coming back to this expression, when delta x tends to 0, this term will simply go away, and that will give you the following result for dy dx, minus 3 over 3x plus 2 squared. And that is the desired derivative for this function. Example 4. When y is given by that function, square root of x. Now that means y x plus delta x is quite simply x plus delta x, square root of that. So delta y is this minus that. So square root x plus delta x minus square root of x. And the ratio delta y over delta x is just that. To simplify this form, we can simply multiply this function up and down by square root x plus delta x plus square root of x over square root x plus delta x plus square root of x. Essentially, we are just multiplying this function by 1. The numerator of this ratio will reduce into x plus delta x minus x. So that is this term times that term over delta x times square root x plus delta x plus square root of x. So in the numerator, that's going to go away, and this delta x will cancel that delta x, which will give you 1 over square root x plus delta x plus square root of x. So that's what delta y over delta x is. 1 over square root x plus delta x plus square root of x. Finally, we can compute the derivative, because this derivative is, after all, the limit of the ratio that we have computed above as delta x tends to 0. And as delta x tends to 0, that's going to go away to 0, and the entire fraction will simply becomes 1 over 2 square root x. And that is the derivative for that function. So you see, all the derivatives can be computed using the first principles approach. Next time we shall look at differentiation by rule that enable us to write down derivatives by inspection. If you find this video useful, please do not forget to like, share, and subscribe. Thank you for watching.